Okay, so a little bit. Okay, a quick review on document model. Actually, last lecture I already reviewed. I already went through quickly, right? How each of the NoSQL model would be. So if we talk about document model, it is clear. It will be clear when you do the practice. It is said to be a specialized key value store. Okay, but if it is a key value that last time you practiced in the lab, okay, I want you to be able to grab the general of the concept, generalization of the concept very well. In terms of implementation, doing the lab and practice and so on, that is, you can master through practice, lab, and do more of the work. But conceptually, you need to get some understanding. So with key value, it is the key, right? Associate with anything, any value, which could be conceptually anything. But when it is document model, the same, you need to have a key. We call it a key. Sometimes, of course, depending on the model you use, the document store that you select and adopt, it may call document ID. That is why. And the value is just a document. What types of documents? I think I already mentioned last time that more or less the main focus nowadays is JSON. Okay. JSON is the most widely used document format, and it gives us opportunity to store through this model what we call semi-structured data. Remember from the very beginning of the class, of our class, we talk about well-structured data, semi-structured data, and unstructured data, right? Where very well-structured data means it is schema-full, meaning that your data need to follow a given, a defined schema very well. And we don't allow kind of flexibility that much, right? When you say that data type must be integer, string, date, or something, that attribute must have the value corresponding to the data type. A record must have strictly 7 attributes in the order 1, 2, 3, 4, 5, like this, and so on. So with the well-structured data, I think we all know very well that relational model or relational database technology give a very suitable answer to handle well-structured data. Not talking about scalability or the size of data, okay? I'm talking about the characteristics of the structure of the data. Okay, then when it comes to semi-structured data, we want to add more flexibility, okay? In terms of the structure, sometimes you want to add extra additional attributes to the thing you are describing and keeping the data, but it's not kind of standard for every entity. Okay, you want that this entity has this structure, another entity follows a slightly different structure, and so on. Okay, so that is what we call semi-structure, more or less. And anyway, we still want a query mechanism to retrieve, to update, to manipulate the data in the way that can understand the internal structure. So this is very different from key value, right? With key value, actually, we don't care about the internal structure. We just look at the whole value as a whole, okay? So this is an example of the supporting data in terms of the document, okay? Which, of course, I think those all of us should be very familiar with JSON, right? We do have the attributes, the JSON format, right? I'm not going to teach in that too detail, but anyway, basic structure is that you can have attributes. I mean, inside a document, this is a JSON document. We call it a document. Okay. Following JSON format. Inside a document, we start with this, end with this. You can have attributes and then associated value for each of the attributes. The value can follow certain data types if you want to restrict them. Of course, you may not want to restrict the data type as well and give the flexibility. So it gives you the choice whether you restrict your document following a schema or not. And you can have nested structure, which is very different from relational model. A relational model, you have very flat structure, but you use foreign key or linking mechanism through foreign key, referencing mechanism. Okay, so let's continue. We were talking about using JSON structure or JSON format so that it allows us to give more flexible to the data that we want to use or maintain. Okay, and with JSON, we can either use simple attribute and value structure, right? This is simple structure with just attribute and value. Or we can have options of having or using arrays of values, or even nested documents or nested structure, and even arrays of nested document or arrays of nested structure. So actually you can go very complex. You can make a complex structure using JSON, right? And this is something that is different from relational model where we only use flat structure and use referencing mechanism. But of course, both have pros and cons. We are not saying that, of course, simple structure has goodness. Complex structure allows certain flexibility. Okay, so let's have some mapping, okay, to understand the idea. But of course, they are different. So the mapping is just to show you how can, I mean, for those who are very much familiar with relational data model, okay, how can we map relational model to document model? If you have a table in your database of relational data model, okay, a table would become collection of documents. Each row inside a table is regarded as one document. Each column could be just one field or one attribute value together with the value, okay? And of course, the whole database is still called database, okay? So these are some kind of mapping. But with the document model, sometimes you can still use referencing mechanism or embedding mechanism, in which we will consider later on in detail. Main operations are similar. You can do create, retrieve, update, and delete or CRUD operations with the document model easily. And okay, any key thing? We can say that it is a little bit schema-less structure. You can restrict your document to strictly follow a schema or not strictly follow a schema. That is a choice, but mostly once people choose to use JSON and document model, they don't want to restrict the schema that much. Okay, so they give a flexible schema and data structure for the user, allowing the structure to change over time easily. And you don't need to, I mean, if you choose not to conform to any particular schema, that means you don't need to define, even not define the schema. So this is very different. When you create a database in relational model, right, the very first thing is that you need to define the schema before you create a data record, a row, right? You need to say that, okay, I want to have table student with ID, with name, with country, with this and with that. And what is the data type of each of the attributes, right? You define schema beforehand. In JSON or document model, you just start with writing your data. That is fine. And once you find that, oh, this is not enough, you need something more, you want to change, just do the change right away. So that's very different. Okay. And that is why I mentioned that very well rigid structure data goes very well with relational model, but a little bit flexible, right? And semi-structured data in which you are not very sure what structure of the data you want to do, you can go with the document model. Start with the document model. Okay, but still, query, indexing, and aggregation mechanism are supported, but you need to practice and see how easy or difficult compare between the two. Okay, flexible schema in action. I'm talking about this example. Suppose that we want to do the same e-commerce application in which you need to maintain a lot of products. And your products, of course, are not on the same type. You are not selling just one thing, right? You sell, maybe this is sports store. No, not e-sport. Sports store. You want to sell everything related to sports, such as bicycle and any tools or things for maintaining your bicycle as well. Each of the products for sure have different attributes you may want to keep. Main attributes can be the same, such as product name, product ID, price, quantity. But if you want to explain and describe your product's detail, right? Each would definitely have different things to describe. Okay. And if you want to in very detail model all those attributes you want to keep, because of course keeping good data, designing the data model, designing data you want to keep for your store will for sure bring values, right? We are talking about data-oriented application. So every aspect of your data of our products we want to keep so that we can do a lot of analysis further on. Which brand goes well, which types of products go well, which variety, and so on, right? So you want to keep all those so that the analysis is possible. but then it comes with the price of the very complex data model, in which if you want to get a single product but obtain a lot of details, okay, such as the supplier, such as the country of origin, such as very many things, product description and product attributes, maybe it brings you to do all these lengthy joins. Okay, what do we have here? For example, we are joining product catalog with attributes, catalog. There are so many things. It depends on the design and depends on how well we keep all those, how fine grained we keep all those details. But this is an example. If we model in JSON, you can have ID, name, brand, catalog, category, type, price. If it is about a bicycle, definitely, as I said, different products, you keep different things, right? Because people may want to search the size of the bike, wheel size, frame set, group set, wheel set, and very many more. There could be more detail. If you are bike lovers, you know that there are so much details to search. But okay, with this, you can group everything in one document together with your bike product description. But and also different products, such as this is a bike category, this is pedal, this is, oh, okay, jersey, the clothing, yes, right? We do sell the clothing for biker too. So different products may have different details that you want to keep, and that's very natural. But map this back to tables. If you do it in relational model, you need to have different tables to handle different types of products, having different attributes, right? So that is why joining would become painful, okay? But here, you just keep, this is one document, this is another document, and this is another document. And, okay, yes. This is the good things with having flexible schema, that is, you can have complex data type, nested, composite, with the array, with the nested structure, and so on, right? And you have the flexibility to change your document or your schema over time. And this is the same as, just to bring this back. And if later on, such as we begin with this, later on we think that, oh, we want to include customer rating into each of the product documents so that we can embed, right, that this product, like this bike, how many customers, what customers think about it, what would be the rating and the review of the customer for that product, right, for each of the products. You can just make the application to add these additional attributes for the comments and ratings easily. No need to change in terms of the schema and so on, right? So that means in terms of developing point of view, this can be easier and taking less time. That is why several of the NoSQL solutions gain popularity to some extent, okay? And of course, there are many ways that you can design your document to model your data. Let's say that I have a new product line, right? I want to sell also, what is this? Baseball glove, I think, right? So I want to sell this. I have some of the detail of the product. The very first thing is similar to what you did in the RDB. You need to design how you would capture all this into a document. So it should be that, okay, let's do it. What is the category? Design the attributes, right? To describe your product based on what you have here. Then you extract something that seems to be meaningful that you want to keep, right? This kind of data analysis and extraction is necessary still. And then you design possible document structure for it, okay? And later on, you can add more. The very first thing is kind of initial draft, and then you add more, okay? Such as, okay, what is this glove model good for, right? Can be for all these positions. You can add more complex structure. You can even have nested documents, the history about the pricing, for example. You can always evolve your data. And variation made easy, which is very different from RDB. With RDB, you have very strict, I would say rigid schema, in which every record of the same table must follow the same schema, right? But when you want to have something different, what do? We add more columns and we leave them now, right? So something like this, if you want to store everything in the same product table, in relational model, you might design your product table to have for sure all these 5 attributes. They are compulsory, right? Cannot be now, okay? You can see they are the same, not now. And, oh, maybe you need to think of another table as a separate table, right? And then connect through maybe foreign key, that another table containing this, if they are bike or bat, sorry, they have this. If the product is glove, may have this. If the product is ball, maybe they have this additional one, or you include everything. And for unqualified, not applicable attributes, you just leave now. That is also possible. It depends on how you would design your relational table. But there are a variety of ways, but of course, still maybe not the very efficient design, not very good design, or lead to a lot of joins and foreign keys. Okay. And you will learn through the lab, okay, that what would be the query mechanism and language or syntax, I would say. How do we query when we want to retrieve the data? You already store the data as a document, right? A collection. Go back here. Your data will be collection of documents. So this one document and another document together in the same file as a collection. So once you want to find something, so this is the database. This is the collection. Oops. I think we define what database we are retrieving, which collection we want to search to find, and then define certain structure or substructure you want to query, okay? Such as find any product that is used for the position in field and has been endorsed by this team. Means that the team has used this before, right? You want to use the same product as the very top team used. And this could be one answer return. That is return. So it has the position in field and it has been endorsed by this team. Okay. Next is that now you understand some kind of the key characteristics, properties, as well as benefits of being very flexible. Okay. In terms of the real document design, still you need to make good design somehow, okay, to capture the data structure, to capture the structure of the data you have for the better model. So I would say we have to still remember when we talk about data modeling. Or even the database design steps. We talk about the phase of conceptual design. In which we make use of what? What model diagram? ER, thank you. ERD. The very first step, right? This is just to capture how data would be for your application and so on, right? In which I emphasize many times that it should be independent of whatever data technology you want to use. It just mentioned about data requirements, data characteristics. So you can still go back to your project. If your ERD is well designed to capture the conceptual model of your project, you still can use it, even for document model. Because the next phase of the logical design is when you already choose which technology you want to adopt. So if you want to choose RDB, here you make tables. Design in the logical phase. In the logical design phase, you say that, oh, we need table student, table customer, table here and there, right? But if you choose to use database technology, which is not relational model, but such as key value, why not? You need to have reasons, okay? Or you want to use document model. You make corresponding design according to that technology you choose, which will result in different results, right? You choose relational database, you will design table, foreign key, primary key, and so on. You choose document model, you will design how you would store your data in JSON. Right? If you choose key value, you need to think what is the key, what are embedding value, Can it really handle the complexity of your data structure? If not, of course, it's not the right technology to choose for your complex scenario, right? Okay. So again, back to your project. Think about it. Your conceptual design needs to be the same, but now you map to different results based on the document model. Okay. For sure, I'm not asking you to use key value to do your project, in which I think you'll find it very struggle because we are not going to force you to choose wrong technology for the problem, right? Key value is good for some easy, some part of the requirement, okay? Okay, so when you're, okay, why I'm here. So the way we make document design still need to base on the relationship you model in the ER, because you can have like, let me go back to the example we used to discuss in the ER running model. We have employee, the running example, remember? Works for, remember, department. Even works on project, right? And what? Cardinality, can someone tell me? Employee and department, what would be the cardinality? Many to one, right? How about this? One here? Many to many, right? Okay, and even more. So still it's the same. You need to transform from this into document, right? Oh, okay. Now these explain. Here you say that we have these many attributes. These will for sure become a document, maybe your employee document with SID something. I think it has first name, some value, last name, middle name, and so on. And so on. If it is just a record of employee, I think this is very straightforward, right? How would you obtain the document model for your employee table, employee entity? But when it comes with relationship, in the past, for relational model, we do use foreign key, right? Employee work for some department, we have DID here, referencing to the DID here for department, right? To say that, hey, I'm working for this department. They are separate table. With document model, you have the choice of doing very many ways. Whether you can have like department as an attribute here, and then you encode all the detail of your department here. These departments have all the things such as name, ID, manager, or many things, right? So you can embed here. So you have choice of doing very different design, in which I will go one by one. If the relationship is one-to-one relationship between entity and another entity, such as this is an example of we can think of this application for also in a company, in which you maintain detail about user. You may have a user document. You have ID and username, maintaining user account. Okay. You can have contact documents, maintaining information about the user ID, the contact information such as telephone and email. And you may have access documents, maintaining about the access privilege that the account can access, such as this user ID has access level 5 group developer. We can use, there are two key mechanisms. There are two key mechanisms, whether it is called referencing mechanism versus embedding mechanism. Okay. For referencing, it's similar to, you can think of it as similar to foreign key mechanism in relational. Each document, remember, a document model is a specialized key value model. That means every document has key, right? It's a specialized key value, so it must have a key. What is the key for each document? If it is MongoDB, okay, we use this attribute name to mean and refer to the key. It's a reserve and it is a standard. You cannot use it for other meaning. It must be just the ID for your document. Okay. So every document would have ID, which can be considered as key. It is key value, right? So it means that ID would map to a single document. Okay, in this. And as I mentioned, NoSQL has kind of no universal standard. So this is what we learn would be very much MongoDB oriented because it's one of the top, right, for the document store technology. If you use other document store engine, query language, and other very many other things could be different. That is not the same as relational model, in which, as I mentioned, you learn SQL, SQL. You can more or less use it for every tool with some slight difference in terms of some small difference, but that is very minor stuff. Okay, anyway, so back to this. You can use referencing, which is similar to foreign key mechanism, in which you split every document, similar to the way you split table. Okay. And you link through mechanism of key or ID. Okay. Such as here. Can I delete? Okay. Here we have, this is already highlighted. Anyway, this is the key of this user document. We use object ID here, which is actually not real ID, right? But it is just to say that there will be Are we disconnected? I was disconnected. Do we still have everyone else? Okay, I hope so. Do you think our friends online is still there? Let's see. Hello, the online students, are you still there?
Yes.
Yes, Professor.
Okay, good. Sorry, I got my laptop disconnected. So I was afraid that our machine from this room is also disconnected, which is not true, right? You're still there? Okay, continue. Where am I? But I forgot to share the screen, right? Okay. So every document has a key, but let's do the practice in the lab. Okay, you map this understanding with the lab practice. Other document, this is doc, such as this is one document, this is another document. Another document can refer to whatever document through the ID, the document ID. So if you define that this will be referred to the other document through this ID, then it will be, you can do the retrieval or kind of join. Okay, similar to join, but this is document join, joining the documents, but similar to table joining, okay? In which, of course, there are certain performance issues that we may need to consider as well. But retrieving documents that link to each other, reference to each other through the ID is fine, it's possible. So we can say that this contact document explains that this user ID has this phone, has this email. This another access document say that this user ID has this access level and group like this. Another way is to use embedding mechanism in which you just embed everything as a nested document structure. And you maintain just one single, in this case, document, instead of having 3 documents here, right? This way with referencing mechanism, you have 3 documents. Here you have 1 document, combine everything. You don't need no referencing. Okay. General recommendation, I'm talking about here 1-to-1 relationship, meaning one user having 1 contact, one user having 1 access control data. When you embed into 1 single document, it's a single here, right? This is this one. Embedded here, this is this one. Okay. General recommendation, kind of analysis of pros and cons. What would be the goodness or the bad thing? Okay. Good things with embed, you like it more, or referencing, you like it more? Which one you like or prefer? Left or right? Okay, but in general, most of the case, embedding or referencing? You like referencing? And how about others? You prefer referencing or embedding? You can use both. Of course, you can even embed this and referencing this. You don't need to just choose one, right? That you embed everything or you reference everything. For some of the content, you embed. For some of the content, you reference, fine. Okay. Good thing with embedding, when you query, it's very easy. It's like you write SQL statement without join. Everything is there in your single table. Your life is very easy. No need to think about joining this column with another column, this table and that table, and having 10 joins, for example. Okay, that is the good thing with embedding. Exceptions or some limitation. If you embed everything, and when your data is huge, it could result in a very huge document. Okay, so both can result to performance issue. It depends. Joining a lot can lead to inefficient query, right? If you join a lot, open this document, that document, and join, of course, it could slow down the query processing. But again, if you have a very large document, it can also slow down the performance. So it depends on the, of course, as we always say, it really depends on the context, the requirement, and the data you have. So here is another example that we use embedding. This is about what? A patient record. This patient has a physician, maybe the owner physician that take care of the patient by the hospital, and has done certain labs or diagnosis and so on. Okay, so think about a patient record. For a lifetime of a patient who may frequently visit a hospital, you can have embedding mechanism so that every of his diagnosis, result of the medication, treatment, and everything is embedded in one document. Or if you use referencing, every of the single diagnosis and treatment and visit to a hospital are separate, right? They are different. The way you design, the way to retrieve. If they have been visiting the hospital for 100 times already, you do the retrieval a lot. If it is a join for referencing, but of course, a single lookup and return you the full record of the patient is easy as well. But that comes with a price to pay. The size of the document for each patient can be expanding, right? So we need to really trade off. Performance will be very good. And that is actually a doctor. If I am a medical doctor, I don't care what technology you're using, right? I just want to retrieve the patient record as fast as possible. And then I can look for the whole history. That is what I want as a user. So user's perspective, developer's perspective, we need to kind of trade off. Okay, designer, database designer perspective also. Okay, that was about one-to-one. If we talk about one-to-many, oh yes, in this case, we're talking about the patient as well, right? For one patient who has a lot of records of treatment, then of course that is one-to-many. Patient, treatment or diagnosis or whatever. Okay, just easy one. This is for sure one-to-many, right? Okay. So if you embed, it will be a record of patients, as I mentioned here before, together with previous treatment, procedures, lab, and results, and so on. Okay. If we make use of referencing, of course, we can do something like this. The patient document is kept brief, very small. The procedures here is the one that I refer to for the treatment. It refers to by the array. This is array of referencing document that we want to referencing to, right? So it refers to this doc as the first one and the second document as the second one, and so on. And they are different documents. So here, this is doc 1. This is document 2. This is document 3. This is a collection, okay? So even if it's in the same collection, but they are different documents, you see, this is the document. Okay, don't think that they are the same documents. Doc 1, Doc 2, Doc 3, and could have Doc 4, 5, 6 for other procedures. Okay. So general recommendations for one-to-many. If this is embedding, right? We use embedding mechanisms here. In many cases, as I said, we always prefer embedding in the sense that it is easy for query, right? For querying, it's very easy and fast. You look up one, you get everything. Okay. Advantages are like this. And pardon? What is the okay. You update it one time, only in one place. One document is updated. Suppose we do, you add more details like this. Suppose another, this patient Joe, right? He comes for another, he has another visit. Then you need to add a reference here. And you need to add that another visit here. So you need to update 2 documents in the one making referencing and in the additional of another one. But if you are making like this, of course, it's one document update by appending a new visit detail, right? Okay. There are some exceptions, of course. As I mentioned, there could be depending on which technology of the document model store you are using, such as MongoDB or some other, they might have some limitation in terms of the size. It's not like unlimited size that you can grow for each single document, right? Okay. And the last types of relationship is when documents, entities have many-to-many relationships among each other, such as this is information about physicians and hospitals. We want to say that these physicians work for these many hospitals, and also this hospital has these many physicians working, right? So it is clearly many-to-many, right? If you draw ER model, it's just like physician entity, hospital entity, and do with the work for, then you have many-to-many relationship. So if we use embedding, of course, we are making duplication. I mean, we make redundancy, right? We say that this physician, oh no, this hospital, this is a hospital document, say that Oak Valley Hospital, it has these very many physicians. And this is another hospital in which you may have the same doctor, right? And you store multiple times. Here, Joe doctor, has been working both. So data duplication will be there. And also the thing the relational database designer doesn't like is that, hey, you're doing it this way. What's wrong? What happened if Joe Doctor changed his address and he works for 100 hospitals? Oh, we need to keep changing the address in those 100 hospitals documents. That is what a database, relational database designer doesn't like, and say that, what if we forget to update one? Then you are making data inconsistent, because it may say in one document that his address is in this, and say different address in another document. Which one is the correct one? That will be the argument, okay, from the relational database designer when we allow data duplication, because data duplication can lead to data inconsistency. Okay. But anyway, we need to make sure, if you're a developer, be sure to search and update every possible record of that Joe Doctor to change the address, right? Then you can calm down the relational database designer to be sure of the data consistency. But anyway, the issue is still there. We will talk about data consistency issue later on. Anyway, when it is referencing mechanism, it will be like this. This is hospital. It just links to patient. In this way, data inconsistency issue would not be a problem to worry. Okay. So to choose for certain scenario, whether you use embedding or referencing, again, you need to really make a trade-off. Embedding make query fast, for sure. Referencing, be sure maintain or satisfy you with the consistent data. Okay, so good thing with referencing is that there is no data duplication, and then there will be no data inconsistency. Hybrid approach is fine, always. So when you make a document structure design, I took this from one project in the year 2020. Okay, it's kind of airline bookings design, data design for flight booking. Anyway, what I would like to show you here, why I'm telling you here, because when you make a document design, the ER design is still there, okay? But with ER design, we don't know whether you are doing embedding, referencing here or there, right? So with this type, there is no standard diagram, but I think this way is easy to understand. It's similar to ER or schema in relational database, right? So you can say that your document would have this structure, whether you want to embed another document structure into it or not. You can see that we make note of some embedding, or where is the referencing? There must be some example for okay. When it is the solid line, this is referencing. But okay, this is not a standard diagram notation. Whenever you make anything, I think you should make some legend. Okay. Or make a clear label. Okay. So we can say that the user this ticket, this is a ticket. Booking, okay. Suppose this is a booking document. The booking document consists of, okay, here we have the booking document. The booking document consists of, for example, booking numbers, data, credit card, and so on. And then it refers to, for example, tickets. And it refers to the user who makes the booking. In this case, you can see that this means it is a referencing mechanism in the document design. And here for the tickets, one booking can make a booking of many tickets. Then it makes use of embedding to embed the ticket information into that document. I'm not saying that this is a good design, but I'm talking about the diagram to tell that how can we first make a document structure design so that you can see the whole picture of your document structure of your application, of your project, for example. So it is a good chance for you to refer to your project now, okay? And then make a document modeling, okay?